So the topic which I am addressing is single point incremental forming. This is a new technique of metal forming, and we are discussing this because the topics which I have shared for seminar are based on this particular manufacturing technique. If we look at the conventional sheet metal forming technique, the process requires a press, and in which we have a die and a punch. The sheet is put on the die and then the punch is traversed in the downward direction. So the shape to the sheet is given by the punch, and in this process bending and stretching of the material takes place. This is conventional sheet metal forming. In this case, the cost of die and punch design as well as manufacturing is very high. So if we want to have mass production of sheet metal parts, then this is a good choice. But if we want to have prototyping or job production, in that case, this would rather turn out to be a costly process. This is a forming limit diagram which shows the strain path on the part formed by the forming technique. So basically this is also called a strain space diagram, where we have a major strain and minor strain. So basically from this diagram we can know the ability of the material to take the deformation before failure. It is also known as formability. Now if we look at the incremental sheet metal forming, right, on which we are focusing today. Basically, single point incremental forming, which we are talking, is a method of incremental sheet metal forming. So the video which you are now watching is actually a single point incremental forming itself. And here we can see that we have mounted a tool on a VMC spindle, and we are traversing that tool on the sheet which is held between two metal plates. So basically we are giving the shape to the sheet by traversing this hemisphere head tool. So here the punch and die is not required, and by looking at the setup you can understand that this is a very simple setup, so it is not very costly. So if you want to make prototype or job production, this can be a replacement or a good alternate of the conventional metal forming process. Now in incremental sheet metal forming there are four methods, right? So first method is where there is no die required at all. We have a tool which forms the sheet. Second method is we have two tools. One tool works as the forming tool, and the other tool work as a support tool, which is below the sheet. Here you can see this is known as double-sided incremental forming. Third is we have a partial die, and the sheet is formed on that partial die using the hemisphere head tool. So that is known as two-point incremental forming with partial die. And the last one is like we have a full die with the shape of the required shape of the sheet, right? And we are forming our sheet on that full die using the hemisphere headed tool. So this is known as two-point incremental forming with full die. Basically, single point incremental forming has been the focus of researchers because it is it is having very simple setup, and it is a very cheap technology. So, and all of these methods can be performed on a CNC machine. So that is an added advantage, because if we know the CNC programming, then we can get different contours using this technique. So this is the simple setup of single point incremental forming. Here we can see we have a blank holder. This is the sheet which we are forming, and this is the SPF tool. That means single point incremental forming tool. The same major strain minor strain plot, which is also known as strain space diagram. If we use the same diagram for depicting the formability uh, obtained by the incremental sheet metal forming, then it is noted that the formability is increasing in this particular technique. Now we can also perform a hole flanging operation using the same technique. Let's say we have a sheet which has a hole on it, pre-cut hole on it, and from this sheet we want to form a flange, right? So the same SPIF principle can be applied here to form the flange, right? And this can be done with two approaches. One is single stage approach and second one is multi-stage approach. In single stage approach, we directly get the flange with the required diameter in a single pass, whereas in multi-stage approach, we incrementally increase the diameter of the flange or angle of the flange to get the final flange. That is known as multi-stage approach. So this is a setup of SPIF. So here in this photograph you can see this is the fixture. The fixture is nothing but these are two metal plates. Then we have one SPIF tool. This fixture is mounted on the VMC work table. The sheet metal is held between these two plates, and we hold the SPF tool in the spindle of the VMC machine, and then we traverse the tool as per the required shape. So this is a very basic setup of SPI. Now there are different research requirements as far as this forming technique is concerned. Like I have noted down some points here. So first one is characterization of the process is required for industrial applications. That means we need to fully characterize the process, then and then we can use it for industrial application. Uh, then we have to analyze the effect of tool size and geometry on the formability. Then what are the effects of process parameters on the formability, that also we need to find. So what are the process parameters? Like we can consider the sheet thickness, the tool diameter, feed rate, step depth, etc. And we can vary these parameters, and we can have a study, experimental study on the effect of these parameters on the formability. Also, we can learn about what are the different tool paths, and we can also come up with some innovative tool path which can have certain advantages. Also, it is required to study the effect of single stage and multi-stage approach on the formability. So these are the some of the research scopes related to this metal forming, advanced metal forming process. And currently, we have already developed the setup of this SPIF at Nirma University, and some projects are already carried out on it, and currently also a few projects are few research projects are going on. This is only one uh, example which I have given here. So this is the work which we have carried out earlier. We have analyzed the effect of tool diameter on the formability in the hole flanging process. So hole flanging using SPIF process. And here you can see that we have formed various flanges with different pre-cut hole diameter, and we have experimentally studied whether it is possible to form the flange successfully from a particular pre-cut hole diameter and a particular size of tool or not. And we have come up with this results that as the tool diameter is increasing, the formability is increasing. Right. So this is just to give you uh, an example about what type of research can be carried out in this SPF. Of course, this is a very basic research definition. Otherwise, some more analytical result or some analysis on strain space can be carried out. So these are the seminar topics which I have offered. So first one is a single point incremental forming. So in this topic, the student is required to study the setup of the metal forming process, what are the different tools, what are the process parameters in this process, and how the formability is depicted, or what are the criteria for depicting the formability. Second topic is single point incremental hole flanging. So in this topic, the student is required to study the application of this SPI principle for hole flanging process, and what are the different process parameters involved, and how the formability is depicted. Third topic which I have proposed is advanced metal forming techniques for automobile. So in this topic, the student is required to study the basics of metal forming in automobile, and then it is required to study the requirements of the advanced metal forming techniques in the automobile field, or rather we can say that we have to identify such techniques which can be applied successfully for meeting the competitive environment of the automobile, right? So these are the three different topics which I have proposed, and the students can just go through it. I have explained everything about the technique, and the students can choose according to their interest. Thank you.